so the last section we're going to take a look at is solving systems of equations algebraically, and different methods you might have used, substitution, elimination. That's the kind of stuff that we're going to look at. So we'll start out with some problems that have two variables. Hopefully that'll be a review of Algebra 1. And then we'll look at some problems with three variables, which is really just an extension of two. If you can do two, you can do three. So remember, a system means that you're solving for more than one variable. Okay, so two equations with two variables is what we're going to start with. Then we're going to do three with three. So that means when you write your answers to these problems, your answer should have as many answers as you do letters in the problem. So if your problem has 2 letters in it, you should have 2 answers when you're done. If your problem has 3 letters in it, like this one, it should have 3 letters when you're done. Right? So you always have as many answers as you do letters in the problem. And then after we do 3 variables, we'll do 10 variables.
What? 10. You said what?
You said 10. Just saying if you listen.
Oh,
all right. Okay. So let's set up the system. We're not going to solve this problem in the first example. We'll solve it later. But I just want to set it up. And they tell us a couple things about a rectangle. That the perimeter of it is 100 and the area is 300. So if we know that the perimeter of a rectangle is 100, what's the formula for perimeter of a rectangle? Yep.
Isn't it 2L plus 2W?
2L plus 2W, that's the perimeter. And what do we know that our perimeter is? 100. So set that equal to 100. So that's the equation for the perimeter. And then for the area, what's the formula for area of a rectangle? Yep. Length times width. And what does it say that our area is?
300.
300. So the length times the width is 300. And for the first part, that's all they want us to do. Not too bad. Now, what we're going to do after I show you something is we're going to actually find the length and the width. But you need both equations to do that. If I just told you the length times the width is 300, you couldn't figure out the length and the width. Because that's just saying 2 numbers multiply together to give you 300. Well, there's lots of numbers that give you 300. There's 301. There's 10 times 30. There's 150 times 2. 60 times 5. There's all kinds of numbers that multiply to give you 300. But they also tell us the perimeter is 100. So we're going to be able to use both of those facts to figure out the answer. Does anybody remember one method that you can use when you're solving a system? Yeah?
Substitution.
Substitution. And there's another method we're going to look at? Yeah? Elimination. Okay. This is a problem that you would use substitution. Okay, so how do you do substitution? Well, there's 3 steps. The first step is you have your 2 equations, you pick one of them, and you solve that equation for a variable. So when you pick an equation, it's going to have 2 letters in it. Which letter should you solve for? Whichever one you think is the easiest. And which equation should you pick? Again, whichever one you think is easiest. So pick an easy equation and pick an easy letter to solve for. Once you isolate a variable, you're going to plug that into the second equation. When you plug that in, then you're going to know one of your answers. So at step 2, you should now know one answer. And you've done like 90% of the work in the first 2 steps. Okay, the last step, which is the easiest step, is to find the other answer by taking your first answer and plugging it back in. Okay, so that's a very general overview of all three steps in substitution. So what we'll do now is we're going to go back and solve that first problem we did. I know I used the letters L and W for length and width. I'm going to change it to X and Y because we're going to start seeing a lot of problems with X and Y. So we just get used to seeing those letters. Okay, but that's exactly the same problem we just had. I just changed the L and the W to an X and a Y. Okay, let's go through these steps on that problem. Okay, first step, pick an equation and solve it for a variable. Which equation do you think is going to be easier to work with? The top or the bottom? Yeah, the bottom has less, I mean, they both have a number on the right, so that's the same. But the bottom one is simpler on the left. It's just two things multiplied versus multiplication and addition. Okay, so let's start with the bottom one. So we pick the equation. And now we've got to solve it for a variable. Which variable in the bottom do you want to get by itself? X or Y? Yeah, X. So we're going to get X by itself. How would you get X by itself in that equation? Yep.
Divide by Y.
Divide by Y. So if you divide each side by Y, you would get that. X equals 300. And then you would divide by the Y. Okay, so that's step one. Pick an equation, solve it for a variable. Step two, plug that back in. So we're going to take 300 over Y, and where are we going to plug it back in?
The X in the first one.
The X in the first one. Right there. Okay, so let's plug that back in, and then if we have to do some simplifying, we'll do that. So the 2y is going to stay the same. You're going to have 2 times 300 over y equals 100. Okay, what's 2 times 300 over y?
600.
Yep, 600 over y. Now, generally, when you're trying to solve an equation, it's easier if you don't have any fractions in it. So what could we do there to eliminate having fractions?
Multiply both sides by one.
Yeah, we can multiply everything by y. Times y, y, and y. What that's going to do is cancel these y's out. Okay, what do we get now if we multiply everything by y? Yep.
2y squared plus 600 equals 100y.
So we get that. And that should look very familiar, that type of equation. What kind of equation does it look like? Yep.
Quadratic.
Yeah, just a quadratic equation. And what's one way we can solve a quadratic? Yep.
Factor.
We could try to factor it if the numbers work out nicely. And if they don't work out nicely, then we can use, let's use the quadratic formula. Okay. Regardless of which way we're going to do it, quadratic formula or factor it, what do you always try to get a quadratic equal to?
0.
Get it equal to 0. So I would move everything to the left. To move the 100y, you would subtract. Now we got everything on the left. And there is one more thing we could do before we start using one of those two methods. Just because of the numbers we have, we could make them a little bit smaller. Yeah?
By everything.
Yeah, we could divide everything by 2. It's not a necessary step, but it will make the numbers a little smaller while we're trying to work with them and get our answer. What do we get if we divide everything by 2? Now, two numbers that multiply to give you 300 and add or subtract to give you 50. I don't think we're going to find nice answers for that. So if you think of things that multiply to give you 300, you've got like 10 and 30, but that doesn't add up to 50. If you try 60 and 50, 60 and 5, 60 times 5 is 300, but 60 and 5, that adds up to 65. So I'm not sure we're going to be able to get something that adds up to 50. So let's just do the quadratic formula. Okay, what's A in this case? 1, and B? Yep.
-50.
Negative 50. And how about C? Yep.
300.
300.
Bless you.
Okay, so let's fill it in. So negative B plus or minus square root of B squared. Well, B is negative 50, and when you square that, 50 times 50, that's 2,500. So B squared minus 4 times, what's going to go next to the 4? Yeah. 4.
4
Yep, 4AC. So 4AC, and that's going to be divided by, yep, 2. All right. So looking at the square root, I can tell we don't get a nice answer there. What's 2,500 minus 1,200? 1,300. So when we simplify that, how many answers do we get? 2. That's why there's a plus or a minus. So it's 2 answers. Okay. And remember what letter we're solving for. We are solving for y. Okay. So let's write down our 2 answers. Okay, they're going to be decimals. I'm going to round them to 3 decimal places. And it's going to be 50 plus the square root of 1,300. Okay, that's the top. And then divide by 2. Okay, so 43.02, we'll say 028.
If we're using our calculators, should we put that in and save it so it's an exact number?
If you had to do calculations with that number in the future, yeah, it probably would be a good idea to save it. And you could even save it as y, because we just found the y value. Yeah, we could save it like that. We're not going to really be doing too many other calculations with it, so rounding to 3 is okay. But yeah, storing it in the calculator is always a good idea for if you need it in the future. Okay, and then y2, 50 minus the square root of 1,300. And now divide that by 2. So 6.972. So this particular problem had 2 answers for y. That doesn't happen in a system unless it was a quadratic. If it was linear, you'd only have 1 answer for y. Okay, but we had 2. All right, so we got y1 and y2, and what do we have to finish up by finding? X. And there's going to be an x1 and an x2. So the last step, plug the answer that you just got back into one of the equations and then solve for x. Which equation here do you think would be the easiest to plug back into so we could get the answer for x?
The second equation.
Yeah, specifically the way we rewrote the second equation, because it already has x by itself. X is 300 divided by y. So just take 300 divided by your answer, and that's what you get for x. So 300 divided by, now I did store that in the calculator, that first answer. I I stored it as y. So I can do 300 divided by, and it'll use the 43.028. And I get 6.972.
Would it make a difference if we stored it or just put 0.028?
A little bit.
Okay.
Yep, a little bit of a difference.
Is that something that would make or break it on the test?
As long as you went to 3 decimal places, it would still be okay.
Okay.
If I don't, I'll show you what happens if we take 300 and we divide by 43.028. You can see it is a little bit
Okay.
different. But to 3 decimal places, it still came out the same.
Okay.
Now, what do you think would happen when I do 300 divided by 6.972? Yeah?
You should get around 43.2
Oh.
something.
Yeah, I get the other answer. This time it's a little off, 0.029, but if I did it exact, it would have been 43.028. So I'm going to write it that way.
If it was on the test and we put 29 instead of 28, would that be wrong?
Again, to 3, it would be okay. To 29, yeah, it would be okay.
28 or 29 would be okay?
Yeah.
Okay.
So what does this mean? We're finding a problem that had a rectangle with a perimeter of, I think it's at 300, and an area of 100. So what's the difference between, this is our first rectangle, and this is our second rectangle? What's the difference between them? Technically there's a difference, but yep.
The X and Y is like.
So how would that look if you drew the 2 rectangles?
It would be taller and then shorter.
Yeah.
But longer.
So if that's one of your rectangles, then your second rectangle is this one. It's really it's the same rectangle, it's just turned on its side. 43 by 6.9 or 6.9 by 43. Any questions on that one? Okay, so that system was a little bit harder because we did have to solve the quadratic there. But once we solved that, that was the hardest part. If you don't have a quadratic, you're not going to end up with a y1 and a y2. You're just going to end up with a y, and you'll just end up with an x. And that's what we're going to do in the next one. It's just going to be linear. So let's try this one. Okay, you might know other methods besides substitution, but I want to try substitution one more time with this one, and then we'll go on to our next method, which is elimination. Okay. So, first of all, is this a quadratic? No? How do you know? Yeah, there's no x squared or there's no y squared. There's no powers of 2. So this is going to be linear, which means when you're done, you're going to have x equals, y equals, and that's it. Okay. Step 1, pick an equation and solve it for a variable. So we have 4 options. You can pick the top equation and either solve for x or y, or pick the bottom equation and solve for x or y. What would be the easiest thing to do here?
The top equation and you solve by y.
Top equation for y. Yep. Okay. And what do you get if you solve the top equation for y?
Negative 2x plus 5.
Yep, negative 2x plus 5. It would have been perfectly fine if you wrote it as 5 minus 2x. Okay, we're not really concerned with y equals mx plus b, but that's always a good way to write it. So that's good. All right, so we solved the top equation for y. Second step. What do I do now? Yep, plug it into the other equation. Anywhere special?
Into the y.
Into the y value. Yeah. So take this, fill that in right there. Now, there's a number in front of that, so make sure when you fill it in, you do it like this. Whatever you put inside that parentheses is doubled. Everything is doubled. So that 2 is going to end up being a distributive property. So that's negative 2x plus 5 when we fill it in. Okay, when you do your substitution, look at your equation, and you should only see a single letter. You might see the letter used more than once, but there should only be one type of letter, and in this case, it's just x. All right. So what would be my next step with that? Yeah.
Distribute.
Yep, distribute. And what do you get when you distribute out the 2?
Negative 4x plus 10.
All right, so we've distributed. Okay. What would we do next? Worse.
Combine like terms.
Combine like terms. And what are your like terms on the left?
3x and negative 4x.
And when you combine that, what does it give you?
Negative x.
Yep. So negative x. Okay, 2 steps left. Yep.
Subtract 10. Divide by negative 1.
Subtract 10 and divide by negative 1. So when you subtract 10, 2 minus 10 is negative 8. And then when you divide each side by negative 1, you're going to get positive 8. So that's your answer. X equals positive 8. So we've got x. What else do we need? Y. And where should we plug this back in to find y? Which equation? Yeah.
The first one. You said 2x plus y equals 5.
So you want to plug it in right here?
Yeah.
Okay, you could plug it back in there. Where else could we plug it back in? Which one?
The second equation.
Can you read the second one to me?
Yes. 3x plus 2y equals 2.
Okay, so you could plug it back in there. I would actually plug it in somewhere else besides those two. Yep.
Oh, you plug it into the green equation? Or
Yeah.
y equals 2x plus 5?
I would plug it back in right there because it's already got y by itself. It's going to be a little bit less work. Okay, so it is the first equation, but it's the first equation rewritten, not the way it was given to us. So this gives us y equals negative 2 times 8 plus 5, which gives us an answer of how much? Yep, negative 11. Now, we didn't do it this way, but we've done a lot of this, what I'm about to say, throughout the year. If we typed these in on the graphing calculator and drew them, what would happen at the point 8, negative 11? Yeah?
They would intersect.
They would intersect. These are 2 lines, and that's exactly where they would cross. So the focus today isn't really graphing, it's algebra. Any question on that? Okay, so substitution, hopefully that was review. Next method is elimination. Okay, with elimination, the goal is to try to get one variable to cancel out. And when you do elimination, you think of doing it in like a column. So we're going to have columns, and everything has to be lined up in like terms. So you're going to always make sure your x's are in a column, your y's are in a column, and your numbers are in a column, just like that. And what we're going to try to do is get the coefficients of one of the letters you pick, either the x or the y, to be opposites, like a 2 and a negative 2, or a 5 and a negative 5. And the way we can do that is by multiplying. When you multiply, sometimes you only have to multiply one equation. Sometimes you have to multiply both equations. We try to avoid fractions as much as we can. Doesn't mean we always can avoid them, but if we can, we try to. When we start getting into problems with 3 variables, I will tell you most of the problems that I give you are going to be nice numbers. So if you start getting answers that have fractions like 310 over 97, you probably made a mistake. Because you're not going to have answers that are that messy. All right, so let's try elimination. So not substitution. Okay, we're going to, the goal now is to get the coefficients of x or y to be the same. Okay, you pick. Do you want to try to get the coefficients of x to be the opposite, or do you want to get the coefficients of y to be the opposite?
X.
Which one?
X.
X. Okay. Well, x is good because one's already positive and one's already negative, and that's what you need. You need one positive and one negative. And now we're going to multiply this equation by something, and I think we're going to have to multiply that equation by something. And we want to think of a number that 2 and 3 both divide into without a remainder. What does 2 and 3 both go into?
6.
They both go into 6. So that's going to be the goal we want. We're going to want to have 6's in front of the x. One will be a positive, one will be a negative. How would we get a 6 in front of the top x? We're going to multiply everything by 3. And you can't just do it to the x, you have to do it to everything. What's my new equation if I multiply by 3? River?
6x plus 9y equals 15.
6x plus 9y equals 15. Now the goal in the bottom equation is a negative 6. Here we're trying to get the numbers in front of x to be the opposite. What would you multiply by in the bottom?
You multiply by -2.
Well, if we multiply by -2, what's -3 times -2?
That'd be 6x.
6.
Oh, wait,
And then
yeah.
6 plus 6 gives me a 12.
Yes, you want to divide by, or not divide, but multiply by 2.
So yeah, we just want to multiply by 2. Just like that. When we multiply everything by 2, you get -6x. 5y times 2, that gives you 10y. And 21 times 2 gives you 42. Now, you're going to add those equations together. Okay? Add them up in columns. What happens when you add that first column?
Cancels out.
It cancels out. 6x, -6x. Second column,
19y.
19y. And third column,
57.
57. Okay, so now we have a very simple one-step equation to get y by itself. What would be our last step to get y alone? Yeah.
Divide by 19.
Yep, good. Divide by 19. And what's 57 divided by 19? 3. Okay, so there's our y. Last thing we need to find, x, and we do this just like we did the last problem. Plug that back into whichever equation you think is easiest. Okay, so which equation do you want to plug 3 back into? Top one. So we're going to plug this in right there. All right, so that'll give you 2x. What's 3 times 3? 9. Equals 5. Minus your 9. And that would mean x is going to equal -2. Okay, you have to make sure you get the right number in the right spot. If you accidentally said y equals -2, no. If you switch the x and the y, I give you partial credit, but you've got to make sure to get full credit, the x is -2, the y is +3. Yeah.
Can we just give you a coordinate for an answer?
If it allowed you to type it in that way, you could, yes. I think I'm going to have 2 separate boxes, x and y. But if there is a question about a coordinate, yes, coordinates is also correct. Yeah. All right, so these are 2 lines, okay? And the problem we did before that was also 2 lines. When you draw 2 lines, I want to look at the number of times they can cross each other. What's one situation that could happen when you draw 2 lines in terms of how many times they cross each other? Yep.
Oh, they did not cross at all.
They could not cross at all. Okay, that would be a special case. So if we try to solve a system like that, and the answer is where they cross, well, there wouldn't be an answer to that problem. Yep.
Wouldn't, sorry, I'm back on this one. Wouldn't it be -14 instead of -4? Because it'd be -9. Wait, no. Never mind. I did my math wrong.
What else could happen besides 2 lines not crossing at all? Yeah?
They could cross
Yeah, in what way? How many times?
one time.
They could cross 1 time. That's like the problem we just did. They cross 1 time, that intersection point is right there. What's the third thing that could happen?
They overlap and they cross it.
Right, it could overlap and they end up being the same line. So 1 solution, no solution, infinite solutions. 2 lines right on top of each other. So far we did this one. X was -2, y was 3. That's a single solution. Now, again, this is just for lines. The very first problem we did, that one was a quadratic. That one was a little different. This is a quadratic. That's a line. So when we did the first problem about the rectangle, there were 2 places where they crossed. Well, 2 is not an option here. When you're just drawing lines, 2 lines cannot cross each other exactly 2 times. They can cross each other exactly 1 time, no times, or infinitely many times. But they can't cross 2. Right. The only way you can get 2 is if you have something that curves like this. That's exactly 2. Okay, so the first question we did was a little different. Let's try this one. Okay. Which letter do we want to try to make opposite here? Yeah. The y? Okay. So what equation would you multiply by a number to make that happen?
The first one by 3.
First one by 3. Yep. So let's multiply that by 3. Bottom one I think we can keep the same this time. You don't have to do anything to it. Okay. What do you get if you multiply the top by 3? Yeah.
6x minus 9y equals 15.
6x minus 9y equals 15. Bottom one, just copy it over. -6x plus 9y equals 10. And now add them up. What's 6x and -6x? That's gone. These cancel. How about -9y plus 9y? That also cancels. So what do we have on the left? 0. And what do we have on the right? 25. Okay, when all your letters cancel out and you don't have any left, that's a special situation. Okay, it's either no solution or infinite solutions. Which one do you think that is? Yeah?
No solution.
Yeah, it's a no solution. Because that is not true. 0 does not equal 25. That means no solution. So if you were to draw both of these lines on the calculator, how would they look? They would be parallel. Yep. To draw them, you'd have to get y by itself, but we could do that, plug it all in, and they would look like parallel lines. more of those. So again, solve. We'll do elimination. What letter do we want to try to make opposite this time? Yeah.
I'd go with X.
Okay, let's make the x opposite. And how would you do that?
I multiply the top equation by 2.
Okay, let's multiply the top by 2. Distribute it. It's going to give you 2x minus 6y equals negative 4. And the bottom one, I don't think we need anything. Just keep it the same. Negative 2x plus 6y equals 4. Okay, what do you end up with when you add all your columns there? Yep.
Inverse operation. Because they're opposite. Or they're the same.
Okay.
Infinite solutions.
And so what did you get there, though? How do you know that?
You just get 0 equals 0.
You get 0 equals 0. Okay, when you are solving a system, if you end up with the same number on the left and the right, there's no variables, that means it's a special case, and you get the same number on each side, that means it is infinitely many solutions, which means if we drew these two lines on the calculator, how would they look?
The same.
They're exactly the same line. Yep. They don't look the same, but if you rearranged it for y, they would be the same. Okay, so any questions on doing two variables? Now, any of the methods that I just showed you, they'll work with 3 variables, 4 variables, and more. Substitution is probably the least friendly because when we start doing substitution with 3 variables, there's a lot to keep track of. So we're going to do 3, but we're going to stick with elimination. Sorry. There we go. Okay, so we'll stick with doing elimination. So I'm going to try to explain it the best I can, but it really doesn't make sense until you just see an example. It's one of those things, it's easier to do it than explain it. So what we do first is you're going to be given 3 equations. You're going to pick one variable to eliminate in 2 of the equations. You can pick any 2 equations you want, and you can pick any variable you want. But you've got to pick 2, and you've got to eliminate 1 variable. Okay, next, you have to pick 2 different equations. Can't be the same 2 you did in step 1. So pick 2 other equations. But you have to eliminate the same variable you did the first time. So you're going to pick 2 other equations and eliminate the same variable again. Once you do that, you're going to be creating a new equation in step 1 that only has 2 letters. You're going to be creating another new equation in step 2 that only has 2 letters. Now you're going to have 2 equations with 2 letters. One equation from here, one equation from here. So now you have 2 new equations with 2 letters. Well, how do we solve an equation with 2 letters? That's what we just did. So now once you have that, solve for the 2 letters. And once you solve for those 2 letters, you'll be able to plug them back in and get the 3rd letter. Okay, so let's just try it. Okay, so there's our problem. So I have an easy way to refer to each of these. I'm going to call this equation 1, 2, and 3. Anytime I write a number and I circle it, it means it's an equation. It's not a number I'm using in a calculation. It's a reference to equation 1, 2, or 3. Okay, so pick 2 equations and eliminate one of the variables. You generally want to try to pick an equation that has a 1 in it somewhere. A -1 is okay as well. But if you can pick an equation that has a 1 in front of the variable, it's a little bit easier. So what do we want to do for our first 2 equations? Let's work with equations. You pick 2 of them. Yeah?
1 and 3.
1 and 3. That's a good choice. So let's eliminate some letter in equation 1 and 3. What letter do you want to try to eliminate in those 2 equations? You want to try to eliminate x. Okay. So we are going to eliminate x in equations 1 and 3. So when we're done, we're only going to have a y and a z. Okay. Let me copy them down. There's equation 1. Here's equation 3. What would you have to do if you want to use elimination and you want to get rid of the x? Yep.
Can you multiply the equation 3 by -2?
Yeah, I'm going to multiply this equation by -2. Okay, so top equation, we're going to keep exactly the same. 2x plus 3y minus z equals -1. If you make an error on this, most of your error is going to come from copies, because there's a lot of copying. The calculations themselves are very easy. Just basic addition and multiplication. All right. What's -2 times x? -2x. -2 times 4y. -8y. And -2 times -3z. 6z. And -2 times -8. 16. Okay. So let's add them up. X's cancel. How about 3y minus 8y? -5y. Good. What's -z plus 6z? 5z. And -1 plus 16. 15. Now, normally I would stop there. That would be my new equation that I'm going to save and come back to. But there's something I can do here. I don't have to. But if I do it, it's going to make that equation even simpler. Yep.
Divide everything by 5.
We can divide everything by 5. Does that usually happen? No. But this time it did. So I'm going to make it. You could do -5 or +5. It doesn't really matter. I'm just going to do negative. I'll do. You said +5?
Yeah.
Yeah, I'll just do +5. So that's going to cancel a 5 from everywhere. And that is my new equation. I'm going to call that equation 4. Okay? -y plus z equals 3. All right. Now I need another equation with just a y and a z. So we're going to do the same thing one more time, but you can't pick equations 1 and 3 again. You do have to eliminate x, but pick 2 other equations, not 1 and 3. Which 2 should we pick? 2 and 3. I would do 2 and 3. Always try to pick an equation that has a 1 in front of a letter. So let's do 2 and 3. Okay, so first part, it's going to take me a minute to copy all that down. So 2 is mainly because I have to keep scrolling, so I can't see it. 3x minus 2y plus 2z. That's equation 2. And equation 3, x plus 4y minus 3z equals negative 8. Okay, and you have to eliminate x. All right, so what could we do there to eliminate x?
Multiply by 3 on the bottom equation. Oh, sorry, negative 3.
Negative 3, yeah. Let's multiply by negative 3. What happens to the top equation? Nothing.
Stay the same.
Nothing. We just stay the same. Yep. So top equation, 3x minus 2y plus 2z equals 15. And what do we get in the bottom? Yep.
Negative 3x, negative 12y, positive 9z equals positive 24.
Yep. Okay. Those cancel. What's negative 2y and negative 12y?
Negative 14y,
Negative 14y. What's 2z plus 9z?
11z,
11z. And 15 and 24?
39.
39. Okay. So we're going to call that equation 5. Okay, so that's the hardest part. Figuring out how do you get down to something that just has 2 equations with 2 letters. Now we've got it down to an easier problem. We're going to solve 2 equations with 2 letters. So now you want to eliminate. You get to choose, but you have to use your 2 new equations. Okay? Use the 2 new ones, 4 and 5. Okay. What letter do we want to try to eliminate from 4 and 5? Yeah?
Y.
We want to eliminate y. Okay.
Why?
We can do y though. It's not a big difference because one's a negative 1, one's a positive 1. I would have went with the positive one with the z, but that's fine. So example 4 plus z equals 3. And negative 14y, 11z equals 39. Okay, so what are we going to multiply the top equation by to make y disappear? Negative 14. Yep. Okay. What does the top equation become when you multiply by negative 14?
14y,
14y.
negative 14z,
Negative 14z. Yep. Minus 42. And what happens to the bottom? Stays the same. Negative 14y plus 11z equals 39. Okay, add them up. What happens in the first column?
as well.
That's gone. How about negative 14 plus 11? Negative 3z. And negative 42 plus 39. Negative 3. So that gives us z. What does z come out to? 1. Once you get your first answer, you're like 90% done the problem now. All right. The rest of the answers come very fast. Okay. Next letter I would solve for is y. I would take equation 4 and plug it back in. Negative y plus z equals 3. All right, so we got z. What was it? Negative y plus z equals 3. Okay. Fill in, now that we know z is 1. Negative y plus 1 equals 3. So what's that going to give me for y? Yeah,
-2.
-2. Right, now we got y. And now the last answer we need is x. Okay, for x, you can pick any one of the 3 original problems, but you got to go back to those and fill in. Which one do you think would be the easiest to use? The first one?
Yeah.
Okay. Well, the nice thing about the third one is it already has a 1 in front of x.
Oh.
So
It's
If
a
you-
1.
if you use the first one, that's fine too. You're just going to have to divide by 2 at the end.
Well, what if I look at
You can divide by 2 then. I won't stop. All right, let's take, I'll do the first one. 2x plus 3y minus z. What was it equal to?
-1.
-1. Okay. X we don't know. Y we know. Y is -2. And z we know. How much is z? 1. So we get 2x. What's 3 times -2? -6. Combine like terms. What's -6 minus 1? -7. And then add the 7, we get 2x equals 6. And we get x equals 3. So solving a system with 3 variables, it's not really harder, it's longer. It's the same thing, elimination, but you got to do it many more times.
We don't put that on the homework, do we?
What's that?
Do we have one of those in the homework?
It's actually
Yeah.
17 of those.
All the problems are 3 variables. No.
Beautiful.
Yeah. No, just I think maybe 2 of them. Okay, so that's pretty much every time you're solving a 3 variable system, that's pretty much what it looks like.
That's
Okay,
it.
you get your 2 equations,
Oh,
and
just
then
that.
and then you simplify that down, and you get your 1 answer, and then you plug it back in.
That's all it is.
Have you
That's it.
Have you seen like big math equations filled with the
Now, when we start to get to more than 3 variables, okay, like 4 or 5, then we don't use elimination like this to solve it, just because it starts to get to too many steps. So there's other ways we can solve systems that are much faster when we start getting into 4 or 5 variables using a graphing calculator. But that's how we can do 3.
Are we doing 4 and 5 variables?
We can.
Are we there learning that?
I wasn't planning on that.
Okay, thank you.
So the faster way to start doing things is with matrices, but that's not something that we're going to get into. If you gave me that same system as a matrix, and I knew how to do it, which I do, I could do it in probably under 30 seconds.
Can we see this?
Yeah,
You
can
don't
we
have
see
to
it? Can we see
explain
this?
anything. Can we just see it?
I
Is
wanna-
the
I wanna
matrices
see
the
it.
stuff that we did last week?
I don't think we've ever done
like that. Didn't we do like
That's
the like?
vectors.
Oh,
Yeah.
I want to see. I want to see it. I want to see it.
right.
And most of the time, the 30 seconds would be me just trying to type it into the calculator as fast as I can.
Can we see that? I want to see that.
Maybe something.
Next week.
Little do you know, Mr. Hager's #1 national rank.